Welcome to Mitchell Maths. In this video we're going to have a look at trigonometry with right angled triangles, and we can use a method with right angled triangles called SOHCAHTOA. Now SOHCAHTOA only works with right angles. If you have a triangle which doesn't have a right angle, you need to use something called sine or cosine rule. The first thing you need to be able to do is to be able to label the triangle properly. And there's three sides which are in the name. There's a hypotenuse, which is H, and the hypotenuse is always opposite the right angle. So if we look at the right angle and we look at the side opposite, that is the hypotenuse. We've got A, which is the adjacent. That means next to. And if we look at the angle we're trying to find, or one of the angles we're given, the adjacent side is the one next to that, which is not the hypotenuse. So I've got the hypotenuse there, I've got the adjacent here, because that's next to this angle. And the last side is called the opposite, and it's the side that's opposite the angle we're trying to find, or the angle we're given. So if I look at this angle here, and I look at the side opposite, that will be O. And in order to determine if I need to use sine, cos or tan, I need to look at what sides I've got, or what sides I'm trying to find. And I'm going to tick them off in SOHCAHTOA. I'll just write it again here, SOHCAHTOA. Right, I've got the hypotenuse, so I'm going to tick off H. And I've got the opposite as well, so I'm going to tick off O. And that means I'm going to use sine, because that's got two ticks. And using this SOHCAHTOA, you can actually use that to write out the formulas. I've got sine angle, which I just use like sort of a theta symbol for that, equals, and if you look at the order, it'll be opposite over hypotenuse. And I can use it to write out the formulas for these two when I need to. So the next one would be cos angle equals A over H. And the last one would be tan angle equals O over A. So by using SOHCAHTOA, I can use that to write out any of the formulas I need. Back to the question. Now that I've got the formula, I'm going to need to insert the values. So I've got the angle written as x at the moment. And the opposite side is 9. So I'm going to plug 9 in there. And the hypotenuse is 15. And what I need to be able to do is I need to be able to separate sine from x if I want to find out what the value of x is. And I'm going to need to take the sine over to the other side. Now there's a special, you can't just divide by sine because it's sort of like a special sort of function. But if you want to separate from the angle, you can do something called inverse sine, which is shown as sine minus 1 on your calculator. So to get sine from one side to the other, we're going to do what's called inverse sine, which will give us x equals sine minus 1, 9 over 15. And if you type that into your calculator, that will give you 45.6 degrees. So that's how you do it. So just remember that in order to separate any of the functions from the angle, you'll need to do inverse sine, inverse cos, or inverse tan. So that's how you work out angles using SOHCAHTOA. We'll now look at sides. In this question, we've got we need to find the value of y. First of all, I'm going to label a triangle. Well, a hypotenuse is that opposite the right angle. The opposite side is opposite the angle we're given this time. So this will be the opposite. And we've got the adjacent, which is next to the angle which has been given. And I'm just going to use the SOHCAHTOA up here just to tick off what I've got. So I'm trying to find the adjacent, so I'm going to need to tick A on both of them. And I've got the hypotenuse, so I'm going to tick H as well. And that means I'm going to need to use cos, because that's got two ticks. The formula is cos angle equals A over H. And now I'll put my values in. So it's cos, well, the angle is 25, so I put 25 in there. The adjacent is y, and the hypotenuse is 17. And now I need to rearrange to get y on its own, because that's what I'm trying to find. And in order to do that, I can multiply both sides by 17. And therefore I'll get 17 times cos 25, which will equal y. 17 times cos 25, you put that into your calculator, you'll get 15.4 centimetres. That's one of the ways. Sometimes what you might need to find is you might need to find the side on the bottom of the fraction. And that's what we're going to look at how to do next. So in this question, find the value of x. We'll label a triangle. The side opposite the right angle is the hypotenuse. The side opposite the angle is called the opposite. And the side next to this angle is called the adjacent. Now that we've labelled it, we can tick off the values that we've got. And we've got the opposite, so I'll tick that and that. I'm trying to find the adjacent, so I'm going to tick this and this. And I know I'm going to use tan, because that's got 2 ticks. And I'll just write out. Usually what I've noticed is when students write out the formula, they have much more chance of putting all the numbers and angles in the correct places. I see a lot of students who try to do it straight off and they quite often make mistakes. Right, tan, well, the angle is 53. The opposite is 5. And you've got the adjacent. So this question is a little bit different because I'm trying to find the adjacent, which is on the bottom of the fraction. And this is a problem because I'm going to need to get the adjacent off the bottom of that fraction. Therefore, I'm going to times by A. And I'll get A times tan 53 equals 5. And then I'm going to divide by tan 53 because I want to get the adjacent on its own. And the opposite of multiplying is dividing. So that'll get me the adjacent equals, which is x is 5 over tan 53. And if you put that in your calculator, 5 divided by tan 53 is 3.8 centimetres to 1 decimal place. So that's the 3 things you can have. You've looked at how to find an angle, how to find a side when it's on top of the fraction, how to find a side when it's on the bottom of the fraction. Now we're going to have a look at a bit more of a complex question where it's not as straightforward. A running track is marked out as shown in the diagram below. Find the distance between points A and B. Now, as you can see from this, we have got some right angles, but it's certainly not a triangle. But we want to find the distance between the 2 points, A and B. And we can use this line to form a right angled triangle by drawing a horizontal line here. And if this is 115, and well, there's going to be a 90-degree angle here, so 115 take away 90 is 25. So I've got 25-degree angle. I also need a side, because I'm trying to find this side here. I need to find one of the other sides. Well, I don't know the horizontal distance, because the distance from D to C isn't given, but I can work the vertical length of the triangle by using 120 and 80, and I'm going to need to take those away. 120 take away 80 is equal to 40. Therefore, this is 40 metres, the vertical length of the triangle. Now that I've got that, I can work out what y is by using the SOHCAHTOA method. I'll just label the sides. So I've got hypotenuse opposite the right angle, I've got adjacent, the side next to the angle, and I've got opposite, the side opposite to the angle given. And if I use this I've got opposite, so I'll tick, tick. I'm trying to find the hypotenuse, which is h, so I'll take the h's as well. I'm going to use sine. And the formula is sine angle equals opposite over hypotenuse. And now I'll put the values in. So I've got sine, well, the angle is 25, equals opposite, which is 40, and hypotenuse, which you can just leave as hypotenuse or you can put as y. And now I need to rearrange the formula. To do that, I'm going to multiply by both sides by y. So I'll have y times sine 25 equals 40. And to separate the y and the sine 25, well, the opposite of multiplication is division. So I'm going to divide both sides by sine 25. And that means, should I put a sign in there? And that means I'm going to have y equals 40 over sine 25. And if you type that into your calculator, that will give you 94.6. And that's in metres to 1 decimal place. So that's having a look at a bit more of a complex one. We're going to have a look at another complex question which involves ratio. A construction firm places 2 metal poles in a ground as shown by A, B and C, D. So those lines sticking up represent the poles. And the ratio of the heights is 5 to 6 respectively. So I know the ratio of A to B and C to D is 5 to 6. And the angle of inclination, well, the angle of inclination means the angle here from A to C. So that's 20 degrees. Calculate the horizontal distance between the poles A, B and C, D. So that's sort of like this distance here between A and D. Now, because I've got the angle here of inclination, I'm probably going to need to draw a triangle here, because if I draw a horizontal line from A, I can get the horizontal distance. And then I'm going to connect this to C. I've got an angle, but I haven't got a side yet. But I can work out a side by using this ratio, because this ratio will allow me to work out what the length of AB is. And once I know the height of AB, I can work out the height of CD. Well, it's a ratio of 5 to 6. Therefore, I'm going to need to divide 18.6, divide it by 6, and multiply it by 5 to scale it to the size of AB. So if I divide 18.6 by 6 and times by 5, that will give me 15.5. So I know this length is 15.5, but this is not actually a length on the triangle. I need to find what the length I need to find is this length here. But I can do that by doing 18.6 take away 15.5. Which is 3.1. So now that I've got an angle and a side, I can use SOHCAHTOA in order to find the missing side, which is this length here, because that's the horizontal distance. Right, let's use the SOHCAHTOA method. So I've got I'll need to label it. I've got the hypotenuse, and this is the opposite, this is the adjacent, and I've got the opposite, so I'll tick that. And I'm trying to find the adjacent, so I need to tick that. And that means I'm going to be using tan. If I write out the formula, that'll be tan theta, or tan angle. That's what that symbol means, theta. Well, the word name for it. So tan angle equals opposite over adjacent. And the angle is 20 degrees, so it'll be tan 20 equals, the opposite is 3.1. So I've got 3.1 over the adjacent, or you can label it as A, or you can label it as Y. Now I need to rearrange this formula, so I'm going to times by Y. So I'll have Y times tan 20 equals 3.1. And then I'm going to divide by tan 20. So I'll have 3.1 divided by tan 20. That'll be my y value. And if you do that and put that into your calculator, that will get you 14.8. And it's in metres to one decimal place. So that's a bit of a hard question, and that's so sometimes you will get ratio, sometimes it will mix topics. This is ratio and trigonometry. Right, thank you for watching. I hope you found the video helpful. To see more videos, please click the subscribe button. And for practice questions, please visit my website, www.mitchellmathsandscience.com. The link is in the description.